of the American Association for the Advancement of Science, or AAAS, and is executive publisher of Science and the Science family of journals. I want to thank you all for joining us, both here in the room and virtually. I'm so excited. This is a big day. This is a momentous day, and I want to thank you for joining us while we celebrate. You know, at AAAS, we are committed to doing four things to achieve our mission of advancing science and serving society. Now, the first of these is that we're going to advance and recognize scientific excellence and achievement, and that's what we're going to do today. The second of these things is we're going to foster the diverse, open, and inclusive scientific enterprise that's essential for that scientific excellence, and that's partly what we do every day. Third, we're going to build trust among scientists, engineers, and the communities in which we live and work, and we do that every day. And then fourth, we're going to infuse policymaking with great science, and we certainly do that every day. But today, we are squarely in that first commitment. We are recognizing scientific excellence and achievement. Now, we're not just going to marvel at the wonders of the universe thanks to a scientific and technical breakthrough. Instead, we're going to honor the people who are critical to its success. Because achievements in science and engineering are attained by people. Science is a social activity. It requires vision and collaboration, sometimes some tension. It requires all those things. And we can recognize these individuals in a very tangible way, in a major way, due to the vision and generosity of one person, Dr. Manny Bhaumik. Dr. Bhaumik's, yeah. Dr. Bhaumik's illustrious career in science and his relationship with the AAAS and science journals dates back decades. It led him to pledging $11.4 million to the AAAS to support a $250,000 annual cash prize for this award. And this prize, the Manny L. Bhaumik Breakthrough of the Year Award, established last year, and this is the first time we're going to award it, recognizes up to 3 individuals whose research and activities were foundational to the annual Science Breakthrough of the Year. And that's the journal's choice for the top research advance of the year. Now, for 2022, science, news, and editorial staff selected the James Webb Space Telescope for the Breakthrough of the Year. Now, it's considered the most complex science mission so far put into space. The JWST was not always guaranteed to get off the ground. It took 20 years to build the Space Telescope, and it faced multiple setbacks. In fact, had any of the hundreds of necessary steps to completion gone awry, the entire project may never have made it. But that's the engineering part. Before that, there was the policy, there was the advocacy, there was the people power, gathering the will of a people to make it happen. And the enormity of this initiative and achievement can't possibly be overstated. It can't be overstated. You know, humanity once gazed into the stars and wondered with awe what was in the farthest reaches of the cosmos, and what are the origins of our universe? And they wanted to see beyond what was visible in the night sky with the unaided eye. And for most of our history, that was just a dream. But because of the diligence of all that have been involved in this project, we're going to see farther and look back further than we ever have before. And that's incredible to me. So to select the winners for this inaugural Manny L. Bhaumik Breakthrough of the Year, Science Editor-in-Chief Holden Thorpe, who you're going to meet here in a minute, convened a committee to select individuals behind the mission representing 3 key groups: scientists, engineers, and the leaders who advocated for the JWST when its status was under the greatest threat. And like all groundbreaking scientific and engineering endeavors that have moved our world forward, the completion of the JWST involved the contributions of thousands of team members. Thousands of people were part of the 2 decades-long work that led to JWST opening its golden eye in July of 2022, and making this an incredibly tough and competitive selection process. Imagine picking the 3 people who were the most responsible for this amazing work of thousands. So today we're going to recognize 3 individuals selected from a distinguished group of professional peers, and their efforts supported large swaths of the JWST community for long periods, and they served as critical champions of this highly ambitious and forward-thinking mission. And their leadership was truly essential. But the common thread to all of them was their persistence in the face of adversity. They advocated for science when it mattered most, and they were relentless in their pursuit of the ultimate goal, getting JWST across the finish line so that the people of Earth could see into the deepest reaches of our celestial home. And when they saw it, they forgot about all those challenges in the past. It's amazing how that works. Now, look, I want to sincerely thank Michael Maloney, the CEO of the American Institute of Physics, and Ellen Stoffen, the Undersecretary for Science and Research at the Smithsonian. They helped us pick these three deserving individuals, part of the committee, along with others that we pulled into this conversation. Thank you. Now, it's fitting that we are honoring these award winners the same year that AAAS is celebrating its 175th anniversary. Now and moving forward, we're going to lean into our multidisciplinary strength to ignite progress for the next 175 years. This award stands out from other scientific prizes and other recognitions because we are seeing the future of problem solving through that very same multidisciplinary lens exemplified by our winners. Now, one person alone can't solve the complex societal challenges that are before us. And we have to continue to advance science in the service of society. And when we bring together people with a diversity of geography, diversity of thought, diversity of experience to approach challenges from a wide range of angles, that's when breakthroughs tend to happen. That's when amazing achievements occur, and that's certainly what happened here. These winners embody that team spirit. They brought different skill sets to the mission, and at different times along its history. We hope that their recognition will inspire future scientists and engineers to embrace this approach to tackle the problems that our society faces. But I gotta tell you, for me, what it exemplifies is that at its heart, science and engineering, including engineering at the scale of the JWST, they are joyous and optimistic pursuits. They are joyous. They require seeing and planning decades into the future, knowing that future generations are going to be required to carry that workload, to carry that workload forward. That is optimistic. There is joy in that. And I'd submit to you that works like these are the pyramids of our time. These are the great stone circles of our era. Without these, the difference between these endeavors, these manifestations of the will of the American people, these manifestations of our curiosity, these aren't built for the benefit of a pharaoh like the pyramids were. They're built to increase the understanding of our place in the universe. They're built to help us understand ourselves. They're built to inspire. They are joyous. They are joyous. And that is inspiration born of extraordinary science and amazing engineering. And that is the 2022 Manuel Bhaumik Breakthrough of the Year. So I want to congratulate our winners. Now, obviously, none of this would have been possible without the support of NASA. And so we are honored to be joined by NASA Associate Administrator Robert Cabana, who will talk with us about this awe-inspiring mission and the three individuals that were gathered here to celebrate. He began his impressive career with NASA as an astronaut, which you're going to see as a common theme today, logging 38 days in space across 4 spacecraft, and included roles as a pilot and mission commander. He also served in various leadership roles, including Deputy Director of NASA's Johnson Space Center in Houston, Director of NASA's John C. Stennis Space Center in Mississippi, and most recently, Director of NASA's John F. Kennedy Space Center in Florida, covering all the various NASA centers. And he just one more factoid about Bob. He logged more than 7,000 hours of flight time in more than 50 different aircraft, 50 different types of aircraft. That's extraordinary. So again, please join me in welcoming Associate Administrator Robert Cabana.
Thank you, Sudeep, for that warm introduction. Thank you so much for having me here today to represent NASA at this honor of presenting these awards to these three individuals. You know, Sudeep, I really liked what you said about the attributes of AAAS at the beginning, the 4 attributes. So I'm trying to top that a little bit. NASA's mission, I think it fits right in. NASA's mission is to explore the unknown in air and space, innovate for the benefit of humanity, and inspire the world through discovery. I can't think of any mission that we have had, any program that has done all of that so well is the James Webb Space Telescope. It meets every one of our mission needs there. You know, at NASA, we say we make the impossible possible. And that's certainly what we're doing with the James Webb Space Telescope. I really appreciate the work that went into selecting these individuals and the areas that they represent. And I think this is really an important recognition. Again, so pleased to be here. Major General Charlie Bolden, administrator of NASA, and it was Charlie. You know, I've known Charlie for a long time. I've followed him my whole career, from the Naval Academy to the Marine Corps as an A6 pilot to test pilot school to NASA, and he epitomizes what a leader is. And what Charlie accomplished with JWST, ensuring that we had the funding for it during his time as administrator, that was huge in enabling this mission. If I look at the cutting edge science that was done with the James Webb Space Telescope, the images are absolutely awesome. The science that we're getting from it, you know, it's going to change our understanding of the universe, but it's done more than just great science. You know, look at those pictures. Look at how they capture the imagination of everyone in their beauty. I love to compare, you know, Charlie helped deploy the Hubble Space Telescope, but I think he'll say that what he accomplished ensuring the success of JWST was absolutely phenomenal. If you look at the pillars of creation, compare Hubble to James Webb, they're mesmerizing. You know, I used to always brag about the Hubble Deep Field picture. I used to tell folks, hey, stick your hand up by the Big Dipper at night and look at your little fingernail where there's nothing. And there are hundreds of stars and galaxies. Compare that to what James Webb sees. It's absolutely amazing what we are learning as we look back 13.5 billion years in time, 350 million years from the beginning of our universe. Couldn't have been done without a great scientist on the team, Dr. John Mather, Nobel laureate. His persistence through, and you said it, nothing great happens without persistence, Sudeep, and the persistence that John had to see this project through to completion, to bring that great science to all of us, absolutely amazing. You know, this was also an international effort. You know, one of the largest international projects ever, led by NASA. We had the European Space Agency, the Canadian Space Agency, international collaboration involving thousands of engineers and scientists, truly a model of teamwork and working together. And space really is a team sport. We don't accomplish anything without working together as a team. How could you do that? Well, you got to have a good program manager too. And Bill Ox, absolutely phenomenal. The persistence that he showed bringing it together. I had a lot of meetings with Bill prior to launch as we were working through everything that we needed to make happen. But Bill, he built that cohesive team working together with everyone in order to ensure the success of this amazing telescope. You know, in the beginning, I mentioned that the telescope achieves NASA's goals and mission. But, you know, I gotta say, none of that would have been possible without the people that make it happen. And that's what NASA is all about. It's about people that bring amazing things to all of us, that open the universe. I'm sure Charlie would say, Bill was really worried about those 138 events that had to happen perfectly to make it deploy. I bet Charlie would say that was nothing compared to getting the funding out of Congress to make it happen. And I know John was sweating the whole time until those first pictures came down. And how beautiful were they, John? Dr. Mather, thank you. You know, it was absolutely amazing. So we recognize them, well-deserved honor, but I know that each of them is more proud of what is coming out of Hubble than being together for this night. So thank you to AAAS for recognizing them. It is extremely well-deserved. I couldn't be more proud to be part of this team and to see these individuals recognized. Thank you.
That's terrific. Thank you. I want to take a moment now to introduce our next speaker, the man who made this award possible, Dr. Manny Bhaumik. Dr. Bhaumik's contributions to the scientific enterprise are vast. I think it's his origin story, his curiosity about the world that really make this gift so meaningful to AAAS and the science family of journals. Dr. Bhaumik was born in a remote village in West Bengal, India, and he and his family had to live through the precariousness of India's fight for independence during his childhood. And his dreams of doing science, of doing things that really were at the cutting edge, brought him to the United States in 1959, joining UCLA thanks to a Sloan Foundation postdoctoral fellowship. There's a lesson in that for everybody. It's important to grab talent from everywhere and to make sure that we are able to be a crossroads for amazing science and engineering. And when he came to UCLA, he began reading Science the magazine, and he says that opened his eyes to diverse subjects and fields, because it wasn't just about the physics that he cared about, just about the engineering that he cared about, but about all of science. And he later served as director of the Laser Technology Laboratory at Northrop's Corporate Research Laboratory. In 1973, he announced the conclusive demonstration of the world's first efficient excimer laser, a form of ultraviolet laser that's now commonly used for high precision machining and for cutting biological tissue and for a whole bunch of other uses, and have paved the way for LASIK eye surgery and many, many other uses. Today, while still a practicing scientist, Dr. Bhaumik has made philanthropy and building public engagement with science a priority in his life. He started a foundation to give back to his country of origin, putting 300 students so far, through university studying STEM fields. In 2017, he endowed the Manny L. Bhaumik Institute for Theoretical Physics at UCLA to support foundational work in quantum field theory and, more recently, foundational issues in quantum mechanics. And 5 years ago, Dr. Bhaumik made his first generous contribution to the AAAS, endowing the Manny L. Bhaumik Award for Public Engagement with Science to support and recognize excellent science communicators. We've got to have those. The author of 2 published books and the creator of an award-winning animated TV series called Cosmic Quantum Ray. So recognizing these significant scientific developments and the people behind them is central to his philosophy. Central. When you see and talk to Manny, you're going to hear excitement. You're going to hear this wonder about the world. And that is the essence of this award. And we are so proud, Manny, to have your name on this prestigious award. Please come to the podium and give us a few words.
Thank you. Thank you. Good afternoon, ladies and gentlemen, and our distinguished honoree for this year. You'll be hearing from them pretty soon. And I must say, it's one of my lucky day, I should say, because there is so much brilliance in this room, I'm almost getting blinded. I just wanted to tell you how this thing started. I started a program way back. Not started, actually, it was going on. And the Science and Engagement Program. And the prize was about $5,000, which, the inflation, it doesn't much very much. So I wanted to make it at least 20. And there was a big fight. No, maybe we'll go 7. So we decided on 10 finally. But it so happened that I've been watching this Breakthrough of the Year announcement by Science magazine, which almost a quarter century now. And people remember what the discovery was, but they forget the names who actually did it. And I thought that we really should rectify that. So I actually, it's really amazing that being a practicing physicist myself, I know how much it means to the scientist to be recognized, even though it's really dichotomy in a sense, because even though they really do not devote all their attention and focus, long hours of work to do something for any incentive, but it comes from inside. And I think somebody here who has been spending almost all his life in this eye in the sky observation, Dr. Laureate Mathers here, he can tell you more about it, but scientists are usually pretty nice people. And as I said, they do it because they feel inside push to do that. But when it comes to recognition, that's another story because sometimes it can be so bitter, it's almost they can beat the mafia in their fight. So, that's because I guess we're all human beings of each other. So we really thrive with recognition and the ceremony that we're having today. So I happen to be having a dinner with Sudeep and Holden Thorpe. There he is, yeah, and Lauren. And I said, we're having this breakthrough of the year. So it's popular almost a quarter century now. And before that, you had a molecule of the year. And people remember the subject, but they forget who has done it, and because they're not recognized. And so I thought that's not really fair. So I proposed to Sudeep and Holden that what about recognizing the people? And I was very surprised after having the fight with the engagement with science to raise it to 20,000 strides. Holden come up with a number of 500,000. And I said, well, he thinks big. So thank you, Holden. That was very nice. I said, we're on. Let's do it. And that was 2020 at the annual AAAS meeting, get together at Seattle. And we didn't know that right in Seattle at the time, the pandemic has begun. And so this idea remained dormant during the pandemic. And as soon as the pandemic ended and everybody came back, and then in a short time, really this was put together. And so it's a very happy day for my life. Thank you very much for making it possible. And I want to congratulate our recipients of this prize. We couldn't think of any better one, a better subject, even though it is only for construction and launch and deployment. But it's only the beginning. It's a new eye in the sky, and the potential is enormous, and already it's changing things beyond our belief. For example, who could have thought that we'll see stars and galaxies forming mere 300 million years after the Dark Ages ended? And not only one. I think Hubble had some indication, but there's some pretty good picture, quite a few, a couple of dozens already seen. And that was totally unexpected. How could the gas, which on the Dark Ages began at 3,000 degrees Kelvin, cool down and clump together to form stars and galaxies mere 300 million, while our cherished standard model, the lambda CDM, says it should take at least 800 million or 1 billion years. So that's already a big surprise. And it certainly doesn't agree with our standard, so-called standard model of cosmology, lambda CDM. So there looks like really it's a big breakthrough, and it's got the work cut out for the theorist to explain how that happens. And I think the first prize started the Big Bang. Almost. And we couldn't have really done a better job. The selection committee, I thank the selection committee for choosing the 3 outstanding people without whom this would have not been possible. And really, your dedication and work and all the connections you have, because money moves things. Getting $10 billion must have been pretty hard. And and also, this is probably the first time you have a instrument itself, even before the results, is chosen as a subject. And most of the prizes are not given on this instrument. Who got the prize for LHC, for example? Nobody. But this is in complexity. I would say, even though it's small, but in complexity and the design, it's really comparable to what LHC has done. I've seen their magnet, how nicely a 100 feet magnet is just a slight curvature to fit in the 17 kilometer diameter. So, but nobody got the prize for that. But this one, it was a very good choice, and I'm delighted that the whole thing has started so well. I want to thank the selection committee, the lady who actually, what is she? Thank you for choosing the right people, because people make it happen, really, and we all know that, and that's the way you have to recognize people. So again, thank you, Sudeep. Thank you, so we, I think, with this start, it will be only better and better. Thank you very much.
How is it that I've known about this award now for several months, and I didn't think of that joke about the Big Bang? How is it that I didn't do that? There's a writer's strike. That's right. That's right. That's right. All right. I now have the honor of actually presenting the Manny L. Bhaumik Breakthrough of the Year Award to our 3 winners, each of whom has led the communities they represented through incredible acts of service and persistence. And I'm going to do this in alphabetical order. So I'm delighted to present the first of the awards to Charles Frank Bolden Jr., a former NASA administrator, a retired United States Marine Corps Major General, and a former astronaut who flew on 4 space shuttle missions. It's his role as NASA administrator that I want to focus on today. He served as NASA administrator from 2009 to 2017. He has the distinction of being the first African-American administrator to serve under the nation's first Black president. A pivotal moment came early in his tenure at NASA. In 2010, when an internal government review panel evaluating the future of the JWST flagged major budgetary problems. And Ellen Stoffen, part of our award selection committee, told us that in the face of that situation, The easy decision would have been to cancel the JWST mission altogether, to give up that dream for this new and complicated telescope to save other stuff. But quitting is the absolute farthest thing from what Charles Bolden did. In part because of his time as co-pilot crew member of the mission that deployed the Hubble Space Telescope in 1990. He knew the potential that JWST had to revolutionize our understanding of astrophysics. He recognized that what we stood to learn from this new telescope would dwarf even that of what we'd learned so far from Hubble. And so in the face of that troubling news about JWST, he responded with courage and with vision by elevating the telescope's completion to an agency-wide priority and ensuring that it remained one. And to do this, he invested a tremendous amount of his own personal time and capital in working with key partners in Congress, at NASA, and beyond to maintain the agency's support for the project. He said the importance of abdicating for JWST during this time never wavered in his mind, even when he was up against strong challengers deeply concerned about cost and time. During his 8 years at NASA, thousands of people were key contributors to the mission. They were key contributors to its ultimate launch and deployment. The selection committee is thus further pleased to present this award to him as a way to represent the whole agency, because so many of the key milestones in the telescope's development happened during his tenure. I want to congratulate you, Charlie. Thank you so much for everything you did. This is an extraordinary achievement. Thank you. Please come on up. Thank you. And you're gonna hear from our winners in just a few minutes. All right, I now have the pleasure of presenting the next Breakthrough of the Year Award for 2023 to Dr. John Mather, the Senior Project Scientist of the JWST since 1995. Now, Michael Maloney on the award selection committee told us that Dr. Mather represents scientists who had a dream about building a telescope like JWST even before Hubble was launched, because it was a complement to Hubble. He played a key role in the $10 billion JWST project from its earliest days. In his work leading the science team beginning in '95, Dr. Mather represented scientific interest to project management and helped see each step forward, no matter how small. This was an incredible challenge of scientific scope and complexity because the telescope represented an extremely revolutionary concept and required the science team to invent many new features and components. Dr. Mather's work to support its development included setting up international science contests to find the best talent to invent the right instruments and technologies and to bring the same inventions to life. As he did this work, Dr. Mather was able to consistently articulate why it was so worth spending time and money on the mission. He's known for speaking passionately about the promise of the telescope, including for making observations about our universe when it was less than 1 billion years old, and as Manny just said, when it was 300 million years old. We heard resoundingly from the selection committee and Dr. Mather's peers that his ability to articulate the promise of the telescope for scientific discovery kept teams going, kept them energized, kept them motivated. And he has represented the hopes and dreams of more than a generation of scientists, and now a new generation of scientists are working on the mission too. And this is what I mean by it being the work of generations and why it is an optimistic and joyous endeavor. And so Dr. Mather, John, thank you. Please join us. All right, wonderful. And so now I have the honor of presenting the the next Manuel Bhaumik Breakthrough of the Year Award for 2023 to Bill Oakes, the JWST project manager from 2011 through the telescope's launch. He represented both the engineering and science teams and came to the JWST project at a difficult time. So the external review that I told you about had just concluded and we knew that the JWST wasn't going to make its launch date. He needed to put together a new timeline for the mission with both a new launch date estimate and a new cost estimate. He worked to learn as much as he could about the mission in as short a time as possible and to assemble a new plan. But he wasn't just focused on the plan. As anyone who knows him would tell you, he was also very focused on the people. When he first arrived to work on the mission, the morale of the scientist and engineer teams was way down. Everybody knew the mission was behind schedule and in trouble. And as project manager, Oakes wanted to bring people together to feel heard and seen. He believed in being a strong listener, managing with humor and building consensus. And Ellen Stofan described the mission as one requiring too many miracles. And she said of Oakes that he knew how to listen, how to make tough decisions, and how to get the team to work together to reach the finish line. One of the miracles that he oversaw was recovery from an incident in 2016 involving the telescope's delicate sun shield, the one that's always talked about being the size of a tennis court, an array of highly smooth mirrors that unfolds in space. So one day in 2016, the sun shield was evaluated in a shake test designed to mimic the rocket launch environment. At first, the results looked good, but after opening the door of the shake test chamber, there were screws, nuts, and washers lying on the floor. This incident put the team back 6 months. It's a major blow. Oakes committed to helping the team pick themselves up and move forward. He worked to build a culture in which people didn't feel burdened by a deadline. He would visit people every shift, encouraging them to focus on accuracy instead of time pressure. If you see something small, tell us now, he'd say. I'd rather lose 30 minutes now than 6 months later. The telescope was successfully launched in December of 2021, and to get to that point required standout project management of both the scientist and engineering teams. And as Michael Maloney put it, Bill Oakes was there to orchestrate all of it and to make sure the orchestra was playing for the launch on Christmas Day, 2021. So congratulations, Bill. I want to congratulate you on also welcoming your first grandbaby to the world. He's going to be looking through that telescope. Second grandbaby. Thank you. Come on up, bro. All right. At this time, I'm going to welcome to the stage the Honorable Dr. France Cordova and Dr. Holden Thorpe, who are going to moderate, it says here a fireside chat, but it's really a podium side chat with our three winners. Dr. Cordova has a distinguished career that spans the scientific enterprise. While her contributions in multi-spectrum research on X-ray and gamma-ray sources and space-borne instrumentation make her an internationally recognized astrophysicist, today she is a highly experienced leader in science, engineering, and education, with more than 3 decades of experience at universities and national laboratories. She has served in 5 presidential administrations, and as the 14th director of the National Science Foundation, where under her leadership, the agency grew at probably the fastest rate up until that point. Her distinguished career in academia includes roles as president of Purdue University, chancellor of the University of California, Riverside, vice chancellor for research and professor of physics at the University of California, Santa Barbara, and head of the Department of Astronomy and Astrophysics at Penn State University. And today, she serves as the president of the Science Philanthropy Alliance, whose mission is to advance scientific discovery through visionary philanthropy. Another incredible distinction of Dr. Cordova's career, and why she makes for a stellar moderator for this award ceremony, is that she was the youngest person and first woman to serve as NASA's chief scientist, and was awarded the agency's highest honor, the Distinguished Service Medal. So please join me in welcoming Dr. France Cordova to the stage. And our second moderator today is our very own Dr. Holden Thorpe, who has served as editor-in-chief of the Science family of journals since October of 2019. He came to us from Washington University, where he was the provost, and from the University of North Carolina, where he was the chancellor. Holden, come on up.
Well, thank you. Thanks very much for giving us this opportunity to talk with you and hear more about this amazing telescope. And congratulations to our winners. It's just really an honor to be on the stage with you. So we have a lot of questions about this mission. And I think we'll start with asking you to give a little bit more color to some of what Sudeep said. He gave some really high moments and some really challenging moments along the very long path length of this mission, which I guess really started in concept in the mid-1990s, but maybe you can explain more about that. I'd like to ask each of you to talk about, because this kind of mission requires such a persistence of leadership, a persistence of vision, decades long in this case. What was the moment when you thought, oh my gosh, all is lost. I've got to get in there and do something and really stand up for this mission, and give us a little bit more color on all the introductory remarks we heard today. John, you want to start?
Okay, well, is this working?
Yeah, it is.
So my role started in 1995 with a phone message from the NASA headquarters. Would you like to work on this project? So I hadn't been paying attention, but I jumped at it and I said, absolutely, that's the most important thing I could possibly be working on. You know, I didn't know yet that I was going to get a Nobel Prize, but I knew this was the coolest thing there was. So I worked on it ever since. I'm very proud that I made that choice.
And we're very happy you made that choice, John. Charlie, how about you? I know you.
Yeah, I tell people and everybody says, yeah, right. My first 2 years as the NASA administrator were disastrous. Let me put it that way. And it was just because I was not prepared for that particular arena, being in the politics and everything else. And what made it even worse was when someone came in and said, John Cassani from JPL has done this, headed up this study team, and we've got some good news and bad news. I said, well, tell me the good news first. They said, well, we haven't thought of it yet, but the bad news is, the bad news is James Webb is behind schedule woefully and way under budget. And I didn't know a lot about DC, but I knew that wasn't good. And then I said, okay, but we need a little bit more detail. Can you go back? Because I've got to go two places. I've got to go to the White House to talk to somebody around the president, and I've got to go down and talk to Senator Mikulski, which was the most important thing. And I said, I want to have my ducks in a row. So we got more detail, and the numbers were bad, but that was sort of the beginning.
And I've faced Senator Mikulski.
Oh, yes.
She's,
Oh, yes.
yeah, that's, yeah, but you did it. Yeah. Yeah.
And I knew that I did not know, let me not go that far. I anticipated that with correct information, she would be a champion for us, because she had championed the Hubble Space Telescope. And she had taken on the administration when we tried to cancel the first servicing mission. And we were able to convince her that she was right, which caused us a lot of trouble, but that was okay. So we got it saved.
John.
Yeah, let me add that report sounded bad the way Charlie said it, but the report actually said did good work, did not do it, did not ask for enough money.
Yeah. That's true, very true.
Bill, how about you?
So I came on board. Even when we launched, I'm still kind of the rookie. So I was only on it for 12 years. So I came on board in December of 2010. After the report Charlie mentioned came out, I was asked to take over. I got called up to the Senate Director's office. They told me what was going on. I said, that sounds really good. I said, what's the chance of Webb surviving? 50-50. I'm like, really? You want me to leave this job I'm doing that's doing really well? 50-50 odds. But it was, I already knew I was going to take it. I was just giving them a hard time. I want to, you did ask about, was there any time in the program where you thought it wasn't going to make it? I never had that. Our
Even
team,
when all those screws and, no.
you know, I've told people this many times. There are 3 words I never heard come out of anybody. I give up. And I never heard the word failure. You know, we had issues, we had challenges. Some challenges a little more frustrating than others. And it was always, okay, what happened? What went wrong? How did we learn from it? And how do we move on? And that was constantly if you had to come up with a motto for the team, that would be pretty much pull some words out of there.
Great.
Wonderful. Well, I just can't tell you how excited I am to be up here with you all. This has been so much fun to work on. And I got to give one more shout out to Ellen and Michael because they were such a huge help. As soon as I knew that could tell that that JWST was going to be the breakthrough of the year, which was well before we announced it. I knew there was one person I needed to have help me, and that was Ellen. And as often happens when I write to her, I got immediately out of office thing saying Dr. Stofan is off in some exotic location, no doubt observing Smithsonian scientists at work. And then about 90 seconds after that, I got an email from Ellen saying, of course, I'll do it. And the person she wanted to have help suggested to help us with Michael. And we had an impossible job, but we also converged on the answer with very little difficulty. So it's great to see all 3 of you up here. We've been dreaming of this for a while. So look, I'm a chemist, and we're living through a very special moment in chemistry because the #1 book on Amazon is a book about a chemist called Lessons in Chemistry. Did anybody else know this? Yes. Yeah, it's actually pretty good. It's not the kind of book I normally read, but if it's called Lessons in Chemistry, then I'm up for it. Anyway, it's about a chemist who she is studying abiogenesis in the 1950s. So the chemists have been thinking about life outside our atmosphere for a long time because based on thermodynamics and everything, it seems like it has to be there somewhere. So Charlie, we'll start with you, but anybody else can chime in. You know, the public is probably most fascinated with whether JWST can tell us whether there's life out away from the Earth. How will the telescope help us do that?
I'm not the right person to answer the question, but because I'm a Marine, and I'll try it. And I will base it on fact or stuff John's told me. We have already, I love the spectrum from one of the earliest sightings of JWST into one of our distant planets or in another solar system that told us that there are elements in the atmosphere. This is my favorite thing, and I talk to kids about this. We are actually looking into the atmospheres of other planets outside our solar system, distant planets. And so when I got the word that JWST had already done this, I thought this was years ahead of when we were going to see this kind of stuff. So I am incredibly optimistic that JWST is going to help us convince ourselves that there is life elsewhere in the universe. And for those of you who are skeptics and say you have no proof, I am a person of faith. And so I will venture into a really dangerous area here. Most of what is the basis for my religion has no proof, but I have faith. And so I have faith in JWST and Hubble and everything else that gives us just enough evidence that it allows us to think and put 1 and 1 and 2 and 2 together and come up with an answer that eventually people prove. So I'm convinced that there's life elsewhere in the universe.
Anything to add, John?
Well, sure. We have a list of planets we're looking at, and we've looked at the best ones so far already this year. So we hope to tell you soon whether there's evidence one way or the other. We're not expecting to see signs of life. We did not design the observatory for that. But we do hope to see signs of water in an atmosphere of a little planet about the size and temperature of Earth. If that's there, that's a very interesting sign. And we need to build another telescope to find that next bit. And actually, the National Academy of Sciences says that's what we should do.
Yeah. Great. Well, speaking of other telescopes, Bill, are you going to build another one?
I retired. so
Okay.
I will gladly be on the review team. For
There
the
you
other
go.
one.
So you worked on Webb and Hubble. Tell us a little bit about how the telescopes are different and the experience of working on both of them.
Well, the experience is a lot different because when I was the manager, and the other one I actually started on when I was a fresh out of college. So the biggest differences are the color of my hair and my body type. But I was on Hubble when it launched. I was working operations when they found the spherical aberration, the disappointment that went with that. I was the servicing mission operations manager for the first 2 Hubble servicing missions, running the ops for the telescope out of Goddard for that. So that was a unique experience. Webb, on the other hand, we talked about what it takes to be, you talk about what it takes to be successful. Before we launched, we did everything you could have done to ensure the success of Webb. I was with my boss, Greg Robinson. We got interviewed by 60 Minutes, and I got asked, "So what's your confidence?" And I said, 100%. I was given a hard time. I won't say by who, but by certain folks. Why did you say 100%? I'm like, well, between the testing that we've done, the people that work on it, I'm 100 now. I didn't say I was 100% that confident we would never have any problems at all. I figured if we have a couple little problems, we're going to overcome them and keep moving forward. It was amazing that we went for that 2.5 weeks of deployments, that we really didn't have any big issues. And that was truly amazing. And that's really a tribute to the team.
Can I add one thing about Bill that he didn't answer your question about the difference?
That's because I've had NASA media training.
The big difference is with Hubble, he is absolutely right. He was a worker bee, a manager. When it came to JWST, he was a leader. And there is a humongous difference between a manager and a leader. We use the terms interchangeably. Leaders inspire people. Leaders make people believe that it's whatever's going on is theirs, and they makes them internalize it and belong. And that's what Bill did incredibly well.
Thank you, John.
Let me add that we were able to do that because we had the support from above. That you and other people after you kept that support alive so we could do what Bill said we did. It took time, took money, took people, and we had it, so we did it.
I wasn't sure how far above you were going, but that's great.
Senator Mikulski.
So I have a question from a 4.5-year-old. So we've proudly heard about new grandsons and all. And so I have a 4.5-year-old, and he FaceTimed me a few days ago and said, Grambo, which is what he calls me. He said, after the Big Bang, he said, then how did everything else get started after that? He said, Grandpa, the stars, and the Milky Way and all that you've shown me. He said, what do we know about that? And I said, well, just hold on, I'll get back to you. No, I did make up something, but John, you're the one to ask about that. So what is JWST going to tell us about those first moments? And it's a big mystery, isn't it?
Yeah, it's still a bit of a big mystery. We have the general picture because we saw the Big Bang material with the Kobe satellite. We made a map of where everything was, and we have a story that there were regions in the universe that were so dense that they could stop expanding and gravity would pull them back together. And then we have the mystery of what happens then. So that's what we're looking at with the Webb telescope. What's the first thing that happened after that? Did the first stars grow and then the galaxies grow around them? Did the first black holes grow first and then the galaxies grow around them? Did the galaxies grow first and then they make the stars and the black holes? So this is still a great mystery of astronomy, part of our origin story. And so the first part is the hardest part because we can't see it until we have the Webb telescope. So that's our job. We've taken a lot of pictures and we've seen already news releases about this and that. But it's a hard problem. Basically, we get a picture with lots of little fuzzy dots, and we have colors and spectra, and now we have acres and acres of paper have been written about what that means. So in a little while, we'll tell you better. But anyway, your 4.5-year-old will have a longer story in a little while.
And hopefully he'll get to participate in that story one day.
Absolutely.
And I know that you all really care about that.
The telescope will still be working when he's old enough to use it.
Mhm. Good. Get him started early. So, Charlie, you and Bob were astronauts, and how does that experience? How did that help you with your NASA role, and in particular with this telescope? I mean, did it give you the strength and courage to know you could?
It didn't give me the strength and courage, but what it did, Bill mentioned the fact of being 100% certain of something, but being confident in the people. I think the biggest thing for me, I said my first 2 years were horrible because I just wasn't used to the environment, the political environment and everything else, but I knew the people in the agency. I had grown up at the Johnson Space Center, and that was half my problem, was that I knew the people, and I wasn't like somebody, say, in the White House around the president or in the Congress who didn't know the people and didn't know what we're made of. And so I trusted them. I selected people like Ellen Stofan to be my chief scientist, or, you know, I didn't pick Bill, but I put somebody in place at Goddard who picked Bill, and we surrounded ourselves with really good people who were strong leaders, and then you have faith in them. You leave them, like John said, you leave them alone. You know, you pick people that are good, and you trust them to do what it was you think they're going to do. Worked for me.
It sure did. And just one question for Bill. I was in French Guiana at the launch site in 1999 for the launch of a mission that I had some participation in. And boy, that's a really different environment than, say, Cape Kennedy, right? So what was it like there? I know on the launch day that I was there was a strike, and they actually closed off the whole place, and you couldn't get in. So they had to helicopter the leaders of the mission. They helicoptered them in so they could just get the launch going. And then finally, at the last minute, the strikers parted, and they let all the rest of us in. But did you have any last minute hiccups, or was everything very smooth for you on launch day?
Launch day was very smooth. It was, you know, it was Christmas Day. We were supposed to go 2 days before Christmas, and then we got delayed because of winds. Nothing with the launch vehicle or that. So I actually felt bad because we had folks that were down there for 3 months. Some of them never went home, and the folks with the little kids now realized that they weren't going to be at home for Christmas. So I really felt bad for some of the folks. But launch day itself was we were up a long time. Myself and a couple of folks that were on console, we had to be on console 11 o'clock that night. You know, launch was whatever time the next morning. So we were pretty whooped. And then because of the fact that you have now commissioning starting and we all wanted to get home, we basically launched and shake hands, give hugs. And then we all had to book back to the hotel, grab our stuff, get on 3 or 4 buses, loads of people. We had a lot of people down there, and head back to the airport. From the time we left the hotel, from the time I got to my place, 19 hours had passed. Say that it was a long day was very much an understatement. But French Guiana was a very neat experience. It's not on my bucket list for traveling to, but it was very cool. The folks down there were great. Being able to go up, the elevator runs alongside the rocket when it was in its vehicle assembly building, and seeing Webb on top and saying goodbye to it was kind of emotional. And on Christmas Eve, there were a few of us that actually got to go to the launch pad, and even though you couldn't see Webb, you knew it was sitting there. Again, it was, I think the best analogy I heard was you're sending your kid off to college, but the kid's not coming back. Right? Well, you really don't want the kid to come back. Maybe there's more of an analogy there than what you want, but there was an emotional tie to that. When you've worked on something for, whether it was my 12 years or folks who've worked on it for 20 years, there's this emotional tie. And the other part of the emotional tie was you knew at this point, folks were going to start leaving the program. And that was hard. I mean, the folks who were down at the launch site, most of them went back either to California or they were going to other programs. As we made it through our commissioning, we all knew we were going to go in different directions at some point. And that's difficult. So anytime we get together, it's like a big reunion, and we just laugh. It's all the things we could have cried about then, like the screws coming out and stuff. Now we laugh about it. You know? Back then I used different words.
Well, Charlie, you're probably the person who spent the most time talking to politicians about funding this and listening to their affirmations, but probably more memorably their objections. What did you tell them when they said, I don't understand why we should spend all this money on this?
Well, I didn't go in by myself. Wes Bush was the CEO of Northrop Grumman at the time, and we made the conscious decision that we were a NASA contractor team, and so we were going to go in as a team, taking equal responsibility for anything that happened. And we both made a commitment that we would elevate this program to our respective offices, which is what I did. And so it became the administrator's project. Chris Scalise, who ended up going out to Goddard as the center director, was the associate administrator at the time. And they run all the people and all the money at NASA. And so that meant that became Chris's everyday activity. Following him was Robert Lightfoot, and that became his everyday activity in the name of the administrator. And so Wes did the same thing out at Northrop Grumman. We actually moved people around. Some people who were doing good jobs, but not good enough, because we knew we needed a different kind of leadership team. And that was pretty hard, to take some people who had been around for a while working a particular project, but move them places. But going in to talk to the congressman, again, with that kind of backup, you know, every time I went in and Wes and I went in, we said, look, this is what our people have told us. And we're guaranteeing that they're absolutely right. And so we've got to do this. Senator Mikulski cannot be mentioned enough. To be quite honest, I'm not sure. My one moment of fear that we were going to lose the project was not when we got the first word, but it was when we found the screws. Because Senator Mikulski was like me. She was on her way out. She was on her way to be with grandkids. And I knew that we didn't have a Senator Barbara Mikulski to go talk to. And that was troublesome to me. The good thing was it wasn't a $4 billion change in price like it had been back in 2010.
These leaders of Congress just can't be undervalued. I mean, there are just.
We give them a hard time,
Yeah.
but let me tell you.
But they give you a hard time too.
But in the science world, they've got to understand something.
Yeah.
You're blessed when you have, especially an appropriator, who not only understands it, but is willing to listen and be convinced that she may be wrong about something. And that was really important. So I can't overemphasize the critical need for cooperation and collaboration. I used to get in trouble because I told people my job is to take care of the people at NASA so nobody bothers them, but also to try to connect that end of Pennsylvania Avenue with that end of Pennsylvania Avenue. And I look around at some people who were here who remember they told me, no, that's not your job. And I said, but I can't get my job done unless these guys down here are talking to the guys up there, and we're in agreement.
You let me say a little bit about the senator. She is a fierce advocate for science, not only our kind of science, but all kinds of science. When she told me sitting on a sofa one day, she was going to be a scientist when she was a little girl. She saw the movie about Marie Curie. She said she was going to be a chemist, and her parents got her a chemistry set. So she was coming in our direction, and then she found another path. And so we're so glad that she did what she did.
Speaking of little girls and boys, I remember once, John, you're telling me your story about growing up. Would you share that with the audience? I thought it was so inspiring.
Oh, yeah, I sort of remember it. I didn't keep a lab book, so I don't really know what happened. But I was about 6 when my dad told me at bedtime that you're made out of cells and there are chromosomes inside. and that got my attention. And by the way, those chromosomes determine your fate in a way nobody understands. That's got my attention. So then by about the time I was 8, see the great meteorite on the floor in the Museum of Natural History in New York City next to the planetarium, and see the planetarium show. I got to do this. So I'm reading books about Galileo and Darwin and learning about science from books on the bookmobile that came around to the farm every couple of weeks. So research farm of Rutgers University, that's where I was in far northern New Jersey. So that was my origin story, and I am completely astonished to be sitting here on the stage with you all.
Yeah, well, maybe Bill and Charlie, you can tell us a little bit also about how you decided to get into this line of work.
Well, I'll tell you, mine is not the example I like to give kids to follow, because I bobbed and weaved I have continued to bob and weave all through life. At the age of 12, we were just, I did not realize John and I are the same month, same year of birth, 1946 in August. And when he was 12, he had other things about science. When I was 12, I liked science, but I had no intention of becoming a scientist. In fact, the only thing I wanted to do at the age of 12, after watching a program called Men of Annapolis about life at the Naval Academy, was to go to the Naval Academy and become a midshipman. I didn't have a clue what was going to come after that. I just knew I was impressed with the United States Naval Academy and midshipmen, so I wanted to be one. 2 things I was not going to do: not going to fly airplanes, not going to be a Marine. So you can, that's why I tell you, don't pay any attention. I tell young kids, don't pay any attention to the way I did it. I just followed my passion. I just, like we all tell kids, find something that turns you on, that really excites you, and then just go for it. My 7th grade science teacher introduced me to science fairs, and I never looked back. I never did not participate in a science fair after 7th grade, and it was because of my 7th grade science teacher. My mom was a librarian, so I was buried in books. My dad was my high school football coach, so that's what made me believe there wasn't anything I couldn't do. He had a saying, it's not the size of the dog in the fight, but the size of the fight in the dog. And so I've always believed in the impossible. Yeah.
So I grew up, watching the Apollo missions and Walter Cronkite, and that really got me interested in space. I got a telescope. And finally I decided to go into engineering, electrical engineering, and coming out of school, I interviewed with a company that's no longer in existence, and there's a Walmart where that company was up in New Jersey. But it was Bendix Guidance Systems Division, and they were a subcontractor to Lockheed on what was then called the Space Telescope, but it was Hubble. And it was just this coincidence that just all the stars lined up. And from there, I worked up there for a while, and then they offered me an opportunity to go to Goddard. Worked as a contractor there for a little bit. And then I ran into a person who had retired from Goddard, but was still working as a contractor. He says, Bill, I think you'd really like working for NASA, which has always been kind of my dream as a kid. And just started doing different things, and worked out somehow that I ended up on Webb, and it was just great.
So let's talk a little bit about science here. And so, John, what's the buzz around with all your colleagues around do you think something new, really new, is in the offing? And obviously beautiful photographs and everything, and people are just starting to digest the data. But there are also papers that are coming out, a number of them now. So what do you see that you think is going to be really mind-blowing, that is making a new scientific inroad here?
Okay, well, to tell you the truth, the things that we're working on now are probably not the biggest surprises, because we haven't been surprised yet. But we started off thinking, well, we really don't understand the first galaxies that I was telling you about, and we still don't. We are seeing pictures that say the first galaxies grew bigger, brighter, hotter, faster than we ever thought they would. So we don't know what's the matter with our understanding, and there's a possibility that there's some new something or other going on way out there that we didn't guess at. So could it be something different kind of dark matter, or the way the dark matter works? Could the dark energy have another way of acting in the early universe? Or are we just confused about really complicated things like how our stars made? So it's all open. And so you'll see in the news that the Big Bang Theory might be wrong. Well, I don't think so. That's too big a jump. We've got pictures of little fuzzy dots, and it's too soon to say we're wrong about such a big thing. But there's going to be something out there. That's where the obvious choices could be for a surprise. And it could be anything else. We could see something about stars blowing up. We already recently found that a star disappeared. So this was not done with the Webb, but another telescope would take enough pictures. Once in a while, you see a star disappear. So where did it go? It turned into a black hole, probably. So that was a surprise. We never thought we'd ever see one. And we'll see. There's surprises coming. And I was surprised by one thing much more elementary. I didn't know what the pictures would look like. I promised people for years, the pictures will be beautiful. I had no idea.
Speaking of that, they're in the infrared. So are those colors real?
No, but we do the best we can. Usually the way we do it is similar to the way your cell phone camera does it. We put the shortest wavelengths are blue, middle wavelengths are yellow or green, and the longest wavelengths are red, because it means something to you and to astronomers, so it makes some sense. But of course you can't see infrared, so we have to make something up. So we do the best we can for you.
So,
Yeah, so I guess another question talking about the news saying that the Big Bang theory or idea is wrong when we have no evidence of that. You know, astronomy is the thing that captures the public's attention the best. I was a planetarium director for 4 years, so I know something about this. And so how do you feel about the way, all of you, about the way this has been received and how the information has been transmitted to the public about what this means? Do you think we're doing a good job at that, or could we do better? And it looks like Bill has an enthusiastic answer here. Yeah.
I just pushed the button on my I have a couple of stories. Before I retired and after we had launched, I went and gave a dark sky talk in Death Valley and one in Bryce Canyon. And after the talks, you have people come up to you and talk to you. When we were in Death Valley, this lady came up to us and she had driven 3 hours to see myself and one of our scientists talk. And, we had some engineering images at that point. There wasn't, some of the beautiful images that came out last July. And as we're talking to her, she started crying. I mean, it was really emotional for her. And, we gave her a little bit of bling and stuff. And then she went over from me over to talk to the scientists. And I turned over and she's crying again. We got an email from a farmer in, I think it was Idaho, that, he's out where there's really good dark skies. And he said, after watching Webb and watching what, just following the mission, we go out at night and look up at the sky and look at it differently than we did before. It's those kind of stories that really kind of drive it home, and what the impact that you had on what you're having on the world.
John, I wanted to ask you about spectroscopy and the mission. There was, last weekend, there was a little convening of some scientists about the Webb telescope. And one of the most startling observations, because we see all these beautiful pictures, is really about the spectroscopy. So you want to talk a little bit about what's new there and what you're observing?
Yeah, sure. So for everybody who doesn't necessarily know what we mean by the word, spectroscopy means spread out the light of your star or object into a rainbow of colors. And so each different wavelength may come from a different thing. So for instance, if you do that for the sunshine, you get a rainbow. You do it very well. There are sometimes dark bars across the rainbow because something in the atmosphere of the sun has stopped the light from coming out. So you can get chemistry of the sun from doing that. So we can do the same thing with distant objects. We also can measure the motions of distant objects running away from us very fast from the spectrum. And because those dark bars show up at different wavelengths because of the motion. And we can tell the temperatures, we can tell so much about it. So from my perspective, we say a picture's worth 1,000 words. Well, the spectrum's worth 1,000 pictures. So we spend most of the Webb telescope time taking spectra because it's hard to do. but so important. So we are now finding out the chemical constituents of atmospheres of other planets. Looking at the inside.
Explain that. That's what I was trying to say earlier.
So anyway, it's the thing we always do in astronomy, because the shape of something isn't enough information. You need to get the spectrum. So we've put an immense amount of effort into designing the spectrometers, so we can even get a spectra of 100 different galaxies at one time. It was so important to us that we had to do this. And it was hard, but anyway, right here in the audience is one of my buddies who invented the equipment to do that. So we're so proud that we could do that. So anyway, short version of a very long story.
Yeah, and some of the spectra, I mean, are you seeing water features? And
yeah, we can see molecules way out there. If in areas in the sky that are cool enough so water can exist, is either as steam or something cooler. Yeah, we see water. We see water in the atmospheres of some planets. Sometimes it's steam because this planet's really hot. Sometimes it's a little cooler, but anyway, water is very, very common. So hydrogen's the most abundant element, and oxygen's almost third, I guess, after that. So it's everywhere. So if you want to know how is the solar system made, well, we got to think about what was the water doing. So we work on other solar systems being born as we speak. We've got pictures of new stars being born with little planets orbiting around them. We think they must be in there. So spectroscopy is what tells us these stories.
Well, this is so great for us to have you here and means so much to us. We've got time for one last question that France is going to ask, and I know it's one that's important to the three of you. So,
well, obviously it takes more than a village to have done this. This is just an amazing feat of many, many people. We thought we'd give each of you the opportunity. We'll start with you, Bill, to mention some of the folks that really have helped you in your work, and then John and Charlie, each of you as well.
Okay, I guess first I'll start with, we talked before, it took 20 years. Well, it was 20 years and 20,000 people. So like you mentioned, it's not really a village, it's kind of a small city that really took to pull together Webb over that time. And I always tell folks it's actually more than 20,000, because for those 20,000 people to do their job, they had to have some kind of support, families, partners, spouses, a pet, a friend, whatever, to do that job. They're all part of the Webb family also. It was a pleasure. I tell folks also all the time that the 12 years I spent on Webb were the best of my career. And it was the best of my career. You know, yeah, challenges were great. Complexity was cool, really cool engineering. Science is phenomenal, but it really was the people. And not only were they brilliant, but they're like some of the nicest folks you ever want to work with. We had a great time. We laughed all the time. I miss that every day. Some of my senior staff is in the back. I see Keith, Paul, John. I see some other folks here. I see Ratton. I see a few other folks around here. Valerie, a whole bunch of folks who worked on Webb who are here today. And Massimo. I know I probably missed some folks now. They're all going to be mad at me. But everybody contributed to it, and it was just a wonderful, wonderful experience.
I think you make everyone here feel that they would like to work for you, Joe.
I'll add one other thing, and I thought about it. I was talking to someone maybe a couple weeks ago, and I said, you know, if someone came to me today and said, and I'm 65 today, at least for another month and a half, you could start all over on Webb, starting today, at the age I am today, and if you had all the same issues and problems, I'd be like, I'm on board. To work with the same people, it's just phenomenal.
Yeah, so I guess my strongest thanks are for Bill, because I worked with Bill every week.
Where's the wallet?
Yeah, so every morning, every Monday morning, I go into his office and we'd have a conference call, and everybody would be laughing when I got there, and we'd be laughing when we got done, and we knew we were doing a good plan. So that's how Bill does things, and I just love working with Bill. So I missed him the minute he left NASA to go to California. I missed him. So, but to thank also the other people that I've worked with. I worked with mostly science teams around the world. We recruited them, we talked to them, we had phone calls all the time with them. We set up meetings with them to make sure we're all on doing the right thing together. And they were a great pleasure to work with too, because they know things I don't know. Of course, everybody knows things I don't know. That's remarkable. People think John is so smart because he got a Nobel Prize. What I actually know is other people know better than I about almost everything. So please let them do their thing and I'll be cheering for them. So that was my management strategy and it's worked pretty well.
I want to summarize with just some people that don't normally get mentioned. And we talked about scientists and engineers and stuff like that today, but we would not have been able, I think James Webb, Hubble, all these big projects, everybody in the world knows about them today. You know, they talk about JWST on Morning Joe, on you name it, you know, CNN, even little bitty stations back in my hometown of Columbia, South Carolina. And it's because of a group of people we call communicators. And when I came on board, there were a few people who came in. One was a person by the name of David Weaver that I believe is the best communicator in the world. He came in to be the head of NASA communications. He brought in young people who knew social media. I didn't even know what social media, this is not that long ago. This is 2019. I had no clue what social media meant or was. That was the key to being able to tell our story. We started something called NASA Socials, where we invited people from all over the world to come to anything we were doing, a launch or anything, and they get yourself there. But then while you're there, we're gonna let you meet members of the team. We're gonna tell you what it's all about. We ask one thing: bring your phone, your computer, your whatever you have that you communicate with the world, and tell people back home what this is like for you. Tell them if it was exciting, say it was exciting. If it sucked, come talk to me first. Tell me why I want you to tell the world it sucked, but saying I've already talked to Charlie Bolden and he's going to do something about it. But it was things like NASA Socials that got normal people involved in telling the story. And I think that's probably the critical thing that we do in our world today, is we try to involve normal people, because we're normal people. You know, we get looked at as exceptional. We're privileged. We are people who are blessed, normal people who are blessed to do extraordinary things. So that's what I'll say.
Wonderful. Big fan.
Really quick, because I looked around and I'm like, oh, I already spotted people I forgot to mention: Jane, Thaddeus, and Begonia.
That's right.
And I'm sure there's more here, and I just haven't been able to look around.
Bill, I
hard
was
enough.
going to ask, seeing Jane Brigby, superb communicator of science, and the others you're mentioning, well, everybody who worked on this mission in any capacity, please stand up and be recognized. Yeah.
Wow. That's all I can say is wow. You know, it's extraordinary what can be accomplished when people are humble and smart and thoughtful and work in teams. And I've never seen three people with such accomplishment be so humble and so team oriented. So I have to, can we thank them again? This is amazing. I want to give a big thank you to Dr. Bhaumik for his support as we close out this ceremony for the inaugural Manny L. Bhaumik Breakthrough of the Year Award. I think we can say that this was definitely a big bang for the very first of these. I think what we can say is that if everyone who wins this award for all the time that is to come, which is forever, if they are as deserving as these three and the 20,000 that come with them, then we are going to make a lot of progress for the world. And we're gonna fulfill our mission of advancing science and serving society. I hope all of you will stay and enjoy the reception that's going to be right outside these doors. Our winners are going to join us shortly. I hope you'll let them get a drink before you mob them, as they should be. And they have graciously offered to sign copies of the Science Breakthrough of the Year magazine that is outside. Please grab a copy, and they will. They've said they would do this for us, which I think is amazing. So get a signed copy of your Breakthrough of the Year issue, and thank you to everybody for coming. Thank you all. Thank you all.